How do you create your own interface? Let's say area. I create an interface called maybe I area is an interface. Generally, the name of the interfaces ends with ER or OR in Go, most of the cases, as much as it is possible. But in C sharp, this is the C sharp way of creating interfaces. Appended with I tells that something is an interface. Many folks follow this approach because you cannot area, you cannot go ends with, you cannot end it with ER or OR. It's not possible. Right. You can create something like this. It's a nice naming convention. I area, fine. So here, what interface contains? It contains a shared behavior. It contains a collection of method signatures or a function signatures, whatever you call it as, or it's a contract or a specification. You can name it as it's a protocol. You can name it as many ways. Area is a function. Area is a signature which returns float 32 variable. Area is what? Area is a signature. This is the signature. This is an interface. This is how you create an interface. Okay. The moment you create an interface, okay, interface in Go language is not different than any variable. Okay. I area is not different than any or empty interface. We know that what is any and empty interface. If you really look at any contains the structure of any contains two things. The structure of any contains two things. Any header I'm talking about, which contains the data pointer and the type pointer. Data pointer contains the pointer to the actual data that any has got. What do I mean by if I create where any1 is any, it contains the header contains two pointers. One is the data pointer and the other one is the type pointer. Okay, data pointer and type pointer. Internal header. You know the header concept. The data pointer contains the actual data, that means 100, and the type contains actually the integer. Now, the data pointer is pointer to 100 and type pointer is int. Pointer to a type called int. So how does it contain the pointer to the type called int? Because when your program is loaded, all the types are, when your program start running, when your application is compiled, it it includes all the types that are available in your system in for your program. It includes all the types. All the types means all the types with respect to your uh, application. All the types with respect to your application. All the types with respect to your application means normal all basic types like integer, float, and all the default types. And if at all you create any new types like structures, user defined types, those are all loaded in the memory and then they contain some pointers. That is what the type pointer is. Fine. So here, if I create a interface, this interface also contains a data pointer and a type pointer. Additionally, there is something called interface definition table or I table. I will discuss about it in a next session. If you are aware of C sharp V tables, virtual tables, which is called dynamic dispatch or runtime polymorphism concept. Actually, runtime polymorphism or dynamic dispatch All these things work on virtual tables in C++. I think also in Java. I don't know, not exactly, but it could be in Java as well, which we call it as a vtable. Vtable is called virtual table. So how this work and all we will discuss in the next session. I don't want to muck up with so much of information over here. Fine. Why I want to tell the difference between this and this is whatever you do type assertion with this, you can also do the type assertion with this. This contains data pointer and type pointer. This also contains data pointer and type pointer and also contains some functional signatures. Right. Let me go and create a type called rect, which is called struct. This struct contain L and B of float 32. Then I got to implement area float 32 return r.l into r.b. Similarly, I contain square float 32. I implement return s into s, but the type is square, so convert it to float 32. Okay, now rect and then square, they are implementing the interface called area because they are implementing the method called area with the same signature. The signature is the same. So these two satisfies this particular interface. Unlike Java, implement iArea, or like C sharp, you don't need to do all these things. This is not required. This is also not required in Go. Automatically Go type system, Go compiler can understand that because it gets loaded in the memory, understand that rect and then square or implementing an interface area. Even if you go to our earlier example, nowhere we told that file writer is implementing io.writer write method. Just with the signature, and then whenever you try to assert it or use it, it can understand that okay, iArea is implementing, sorry, rect is implementing iArea, square is implementing iArea. You don't need to specially go and then tell about it. You don't need to explicitly go and then declare that hey, the IA rect is a type, it is going to implement, it is implementing iArea. No need to tell that. Go can understand. Let's say I create a variable called R1, which is new rect R1 dot L equal to some value, and then two interfaces are having the two, not two interfaces, two types are having the same method. Ah, okay, let's say I create another interface. Okay, sorry, interface. I give maybe I area one. Okay, and then this got to be my method. Oh, okay, okay. Now see, two interfaces are there. Okay, actually, in fact, Rect is implementing both iArea and iArea 1. Fine, I'll show you that. So, how can I assign R1 to interface where iArea 1 is iArea equal to R1? So, how do you call it? fmt.println area, area of R1 is iArea1 dot area. You are calling with an interface. You are calling with an interface. Fine. I'll tell you. Let's say, so it can automatically assigned. This is what the thing is. It is automatically assigned. This is, you don't need to tell that. This is qualified. Let's say I area 1 has got something called maybe display. Okay, now an interface variable. You are creating a variable of interface. Then the part of this particular interface is assigned to that area because it's an interface. It's an interface. You can directly call with the interface. Let's say I create another one which is called R1, like this. I create S1 equal to square. Okay, I'll do like this where S1 is square equal to some value. Now I can give the same I area equal to S1 and then area of S1 equal to I area of area because this is an interface. R1 and S1, that means the rectangle variable and the square variable are implementing the interface. So you can assign R1 to I area variable, as at the same time you can also assign S1 to I area variable because both of them are implementing the interface. Both of them are implementing the interface. So interface contains what? Interface contains some signature. What you are telling that, okay, I'm creating a variable of interface and then I can either give the value of R1, a variable called R1, or variable of S1 because both of them are implementing the interface. Both of them are implementing the interface. Let's say that I create a new variable called where I area 2 of I area 1. Now I area 2 equal to R1 doesn't work. Why it doesn't work? Because R1 is not satisfying the interface because there is also a method called display. We have not implemented this method. So I area 1 is, for example, if I remove this, then this is possible. This is valid. This is valid because ultimately what I area is an interface. I area 1 is an interface. What does it contain? It contains two things. What do those two things are? The data pointer and the type pointer. Okay, the data pointer and type pointer. You see it. What is the data pointer? R1, the address of R1. Here the address of R1. What is the type? The type is rectangle. What does that rectangle contains? It contains a function called area. It is satisfying to the interface. So you can use the interface. See, the concept is same. The concept is exactly same with respect to Java and then C Sharp. I mean, internally concept is different, internally how it works and all, but interface concept is same. The only difference is you don't explicitly tell that what interface that Rect is implementing. As long as it is implementing the method, it satisfies the interface, whether the interface could be iArea or iArea 1 or something else. Maybe I can put it as I shape. Okay, it also contains, it also implement I shape because it is satisfying this interface. That is the most important thing. How does it know whether it satisfies the interface or not? Because of data pointer and type pointer, it holds of that particular address. The moment you create a variable, again this is type safe. Remember that the concept is type safe. Okay, many of us think that how could it be type safe? Because one time you are giving R1, the other time you are giving S1. How can you say it is type safe? How can it does it? The compile type safe is what? Type safe is what? Nothing but compile time analysis. The compiler should know exactly what types it is working on before going to compile. It's not a dynamic, it's statically typed. Sorry, I'm sorry. Type safe is a different concept. Type safe thread. So yeah, type safe. Of course, the concept is same. Statically typed. How it is type safe? The reason is the types are aware to the compiler at the time of compilation. How they are runtime, how they are assigned is different. But still the compiler know. The compiler knows that what is I shape, what method that what signature that I shape or I area contains. The compiler knows that what is a rectangle, what does the rectangle contains, what methods that the rectangle implement. The rectangle implement a method called area. The square implement the method called area. And the area, the signature of area and the signature of rectangle satisfies I area and then I shape. So you can give either I area or I shape. There is no problem at all. It works. It perfectly works. Okay, there is no issue at all. Let's say I create something called display. Simply I implement something called display function. See, the concept is very simple. Wait a minute. For example, it contains a method called display. Okay. Now, now both of them even satisfy display. Okay, I area one dot display. Here also I area one dot display. Okay. I area one dot display. This is gonna print a rectangle. Here I area one dot display. It is going to print square. Okay, it's going to print square because here this interface contains R1, which is called the rectangle object. Here it contains the data pointer is towards the rectangle. It maintains another table called iTable. I will discuss about it in a next session. iTable. Okay, which we call it as an interface definition table. I will explain about interface definition table in the next concept because I just want to give you some introduction about interfaces. So what is the difference between Java? Let's take an example of Java and Go language. Java, you need to explicitly tell that this rectangle class is implementing iArea or iShape. Then only it can satisfy iArea. You cannot say that iArea and iShape without explicitly telling. You can say implements iArea comma iShape. You need to give the details of all this uh, during your program. The compiler, you should tell the compiler that a rectangle is a class, for example, in Java, which is implementing iArea and iShape. But Go, that is avoided because already the compiler is aware. Compiler is looking at the code. Compiler knows that rectangle is implementing area, rectangle is implementing display. Why should you go and then say that it is implementing area? If you want to use area, as long as this particular type is implementing the signatures collection of methods or collection of method signatures that iArea has it's implementing these methods, then let's consider it as part of an interface. Let's consider it as a qualified variable to be given to an interface variable. Nothing explicitly you should tell. It can understand the compiler. So additionally, what Go does is you don't need to explicitly tell. Other than that, everything else is same from the uh, application perspective. You don't need to tell here. Compiler understand. The concept is compiler understand this. Okay, rectangle contains a method called area, method called display. Since you want to, at the moment the compiler sees that you are assigning R1 because it is compiled. The moment compiler sees that you are using R1, let's say I remove this display for the square. Okay, I remove this method for display for the square. So the compiler, the moment you compile your application, compiler understand that compiler understands that Square does not implement area because the display method is not implemented for the square. The display method is not implemented for the square. Since the method display method is not implementing the for the square, the compiler itself is prohibiting it. It is saying that hey, you are doing something wrong because I S1, which is called square, does not implement this interface. How can you assign S1 to a area which is an interface? It doesn't implement. That is the concept. So the only difference is compiler is more intelligent. Intelligent means it doesn't want to put lot of keywords and stuff like that. They just want to make it as simple as possible. So compiler is very intelligent. Compiler is very intelligent here to understand things instead of you explicitly go and say. That's only the difference. Don't get confused by yourself what exactly it is doing. Since you are not see, for example, if it is in C sharp, you need to do like this. I area, I shape. If it is a class and not a struct. But here you don't need to do that. That is only the difference in Go. Okay. So two things. This is also some folks call it as a polymorphism. Why I explained polymorphism earlier in the previous session uh, is here 50th example. The reason is this is also called as polymorphism in Go. Some folks say that how do you implement polymorphism? Number one, by implementing empty structs or structs with type as well, but generally why empty struct is without holding any size you can. And the another way is by implementing interfaces. Okay, next session we will see that what is itable, what is interface definition table, also called as itable, what does it contain. There is a concept called monomorphization, how monomorphization work in other programming languages, how it is avoided in Go language, what is static dispatch, and then what is a dynamic dispatch. Dynamic dispatch is nothing but runtime polymorphism. How runtime polymorphism is achieved in Go language by embracing the itable or interface definition table by using interfaces. We will discuss in the next session. Okay, that's what for today. We will connect tomorrow and then continue the session. Yeah.